Imagine a being so powerful it can suck in entire galaxies, so mysterious it's invisible to the naked eye, and so impressive it bends the very fabric of space and time to its will. Yes, meet my mother. Just kidding. Actually, meet the ultimate superhero of the universe, the black hole star. What is it and how does it work? Well, let's find out. The universe is full of marvels, and the black hole star is one of the most impressive ones. It's a supermassive force that can bend the laws of physics and a true enigma for scientists to unravel. No wonder science fiction writers find them so captivating. A black hole star, also known as a quasi-star, is a hypothetical type of extremely massive and luminous star that may have existed early in the history of the galaxy. They're predicted to be as luminous as a small galaxy, but unlike modern stars, they weren't powered by nuclear fusion in their cores. A quasi-star's energy would come from material falling into a black hole at its core. And yes, just like a normal black hole, these stars have the power to suck in anything and everything that gets too close, including stars, dust, and even entire galaxies. But how is it possible that the star is born from a black hole? And what's more, how do they continue to coexist together? Well, first let's discuss how black holes are born in general. It all starts with a supermassive star, one that is at least a few times more massive than our own Sun. This giant of a star burns bright and hot, shining with the light of 1,000,000 suns. But eventually, it runs out of fuel and its fate is sealed. As its lifespan comes to an end, it makes one final massive boom, a blast so powerful it can outshine an entire galaxy. This blast is called supernova. During this boom, the outer layers of the star fly away, while the core gets squished together by its own gravity. If the squished core is heavy enough, it can keep squishing until it becomes a black hole. And just like that, a black hole is born. Don't even try to put diapers on this thing. Now, this cosmic monster baby can continue to grow by swallowing up anything that comes too close, including stars, dust, and even entire galaxies. This is basically what's happening now in our universe with supermassive stars. But what about quasi-stars? The formation of a quasi-star could only happen early in the development of the universe, before hydrogen and helium were contaminated by heavier elements. And because of that, quasi-stars have one important feature. They are gigantic, so enormous that it's literally impossible to imagine. They may have been dwarfing even the largest known modern stars, like VY Canis Majoris and Stephenson 218. No wonder they're so scary. They were born from protostars, one of the first stars in the universe, the great-great-grandfathers of, everything. So now imagine a protostar so massive that its core collapses into a black hole, just like we described before. But the key difference is that in a regular supernova, the outer layers of the star are blown away by the energy released during the boom. Meanwhile, in a quasi-star, these outer layers are massive enough to absorb the energy without being blown away. What do we get in the end? A star with a black hole in its core that weighs from 1,000 to 10,000 solar masses. This quasi-star is about 14,000 times bigger than our Sun, which makes them bigger than any star we know today. These celestial titans have some pretty crazy properties. Once a black hole is formed at the center of a giant protostar, it starts to give off a ton of energy. This energy helps to balance out the force of gravity, making it kind of a giant fusion-based star. They would be so bright that each one would look like a small galaxy. Quasi-stars would have a pretty short lifespan, around 7 million years. Just for comparison, our Sun is about 4.5 billion years old, and it's only halfway through its lifetime. But either way, during this short period, the black hole at the center would grow to be about 1,000 to 10,000 times the size of our Sun. Quasi-stars are also thought to be super hot, with temperatures reaching over 17,500 degrees. But as a quasi-star gets older, it starts to cool down, and its outer layers become see-through. Eventually, it cools down to a temperature of 6,740 degrees, and at that point, it's curtains for the quasi-star. It can't survive at that temperature, so it just dissipates, leaving behind an intermediate mass black hole. Unfortunately, right now, there's no observational evidence for the existence of quasi-stars. This is because they're thought to have only existed a very, very long time ago. They may have been very massive population 3 stars, which are extremely rare and difficult to detect. It's also very unlikely that any of them would still exist today because of their super short lifespan, only 7 million years. So why do scientists believe that quasi-stars could have existed? Because they're looking for ways to explain how supermassive black holes formed so early in the history of the universe. They're found at the center of most galaxies. But how could these monsters have formed so quickly? After all, it takes a really long time for small black holes to grow into supermassive ones. This is where the idea of quasi-stars come in. These stars aren't just destructive forces of nature. They're like the black belts in the martial art of gravity. They can bend and twist anything to its will. That's why these stars, if they really existed, had to play a crucial role in the evolution of galaxies. They must have been instrumental in shaping the universe as we know it. So, those intermediate-sized black holes that they left behind could eventually turn into supermassive black holes in the center of galaxies. But we're still yet to solve this cosmic mystery. Detection and study of black hole stars is like trying to find a needle in a haystack. Only instead of a needle, it's an invisible and mysterious object. And instead of a haystack, it's the vast expanse of space. But with the help of some pretty cool technology and a lot of brainpower, scientists are getting closer to uncovering the secrets of these celestial giants. Here are some things that can help us in this research. First of all, gravitational waves. They're like ripples in the fabric of space-time, caused by the movement of massive objects. Albert Einstein predicted them way back in the 20th century, but they were finally detected only in 2015. We caught them by observing the collision of 2 black holes. This discovery confirmed that black holes can merge and that they're a powerful source of gravitational waves. Scientists think that by studying these waves, they can learn more about how black holes form and grow. We can also try to detect quasi-stars by observing the effects of their gravity on nearby objects. It's like trying to spot a criminal by their fingerprints. For example, if a black hole is located near a star, scientists can observe the star's light being distorted as it's pulled toward the black hole. And of course, we can use our technologies, such as X-ray, infrared, and radio telescopes. This allows us to study black holes in various ways and at different stages of their lives. In other words, scientists are working hard to uncover the secrets of these celestial giants. We develop new telescopes, search for primordial black holes, and try to understand the connection between black hole stars and dark matter. And we're making some pretty incredible discoveries, just like with gravitational waves. All these things will bring us closer to uncovering the secrets of quasi-stars. And when we find out the truth about them, it will become a new page in our scientific history.
When you look at the night sky, it seems like there's not much happening up there, and that the stars always twinkle at the same spot. For thousands of years, researchers followed the idea that the lights in the sky were unchanging. Sailors guided their ships using fixed stellar patterns. There are also the exact outlines of constellations we observe today, and astronomers identified them a long time ago. It seems impossible that one day we wake up and simply can't see some stars anymore. Or does it? A team of researchers at Vanishing and Appearing Sources During a Century of Observations, or VASCO, studied the sky to check how things with the stars are going. The astronomers got the data from Gaia, the European Space Agency, and compared the information from 70 years ago to that from today to see how the sky has changed. To test it right, they had to use both modern and old telescopes. And something really interesting happened up there. Over 700 stars from the old maps were missing. If one star disappears, multiple theories could work. But it's harder when hundreds of them vanished at the same time. Could it be that the data was wrong, or these stars were too faint to detect? Nope, they quickly eliminated this option because these stars had clearly been part of their earlier observations. So, the first thing that comes to mind when talking about how stars disappear is that they reached the point where they ended their lives. You can have the most massive stars of all, and we're talking about those that are way heavier than our sun, and they go through sudden changes as they get to the end, which we also call a supernova. It's a powerful explosion that later shines for many, many months, and it's still visible even across hundreds of millions of light years. But that's the point. You see the traces, unlike here. Could this be a failed supernova? That means maybe one of them collapsed but turned into a black hole and consumed the remains from the inside out without causing a powerful explosion. But no one's been mentioning any signs of a black hole being active anywhere near those stars. And what if the stars had become less visible because of dust or gas around them? This is something that can easily happen, as interstellar dust and gas do block our view of objects that are far away. But there were no traces of unusually high concentrations of dust or gas. Nothing destroyed them either. Researchers would have seen traces if something like that had happened. Plus, these missing stars were not all in the same area, which means there probably wasn't just one fatal thing that made them all disappear. Also, the stars were not at the same stage of their life, so it's not an option they were all accidentally close to their end. They weren't particularly old or young, and they were on different levels in size and brightness. At some moments, it even seemed these stars haven't vanished because of some natural events. Maybe it was something related to other civilizations that might be somewhere out there in space. Maybe that's one of the ways to look for them. We could stumble upon some secret civilizations from other planets if we carefully observed the behaviors of stars, especially those we can't explain. No one knows what exactly happened with the missing stars, and unfortunately, right now, all we have are these theories. But you have to admit, they're cool though. Maybe it's just some kind of optical afterglow caused by gamma-ray bursts, or maybe even fast radio bursts. Fast radio bursts are powerful pulses of radio waves. They can release more energy in a couple of thousandths of a second than our giant sun does in almost 100 years. We don't really understand how these energy eruptions work yet, so we don't know what they can do. But still, hundreds of stars at approximately the same time. There are between 100 to 400 billion stars in our galaxy, so we'll probably see some of them disappear too. Hopefully, we'll understand better why such things can happen. Of course, scientists are not sure about this number because we can't see all of the Milky Way stars from our home planet. Some are too faint, some are too far, or even hidden by dust or gas. But they assume these numbers based on the size, shape, and likely mass of the Milky Way. And out of billions of stars, there are a little over 9,000 of them we can see with the naked eye. If you want to see more, you need a good telescope that will reveal those fainter ones your eyes are unable to discern. Many of the stars we see in the night sky are probably not alive anymore. Stars are giant balls of gas that produce light and heat through nuclear fusion in their cores. However, stars also have a limited lifespan, and eventually, they run out of fuel and stop shining. When a star passes, it can either become a white dwarf, neutron star, or black hole, depending on its size. Scientists have discovered that some of the stars we see in the night sky are too old to still be shining. This means that they may have faded, but we are still seeing their light because it takes so long to reach us. Actually, we may be looking at the past when we look up at the stars. Check out all of the stars you can see with your bare eyes. They lie within about 4,000 light years of us. That means what we're seeing are stars that appeared 4,000 years ago. Most of the stars we know of exist within galaxies, which are massive collections of stars, gas, and dust held together by gravity. Still, there are large areas of empty space between galaxies too. And the question is, could they have any stars? It seems that these areas of space are not completely empty. There is still some gas and dust, as well as dark matter, which is a type of matter that we cannot see but we know exists, because of its gravitational effects on other objects. Scientists have even discovered a few isolated stars in these areas of space. These stars didn't form there. They ended up there by accident, which means they have probably been ejected from their galaxies by gravitational forces or collisions with other objects. And there could be more of these stars than we realize, but they are simply too dim to be seen from Earth. Stars don't actually twinkle. It's more that we just see it like that from the Earth. It seems like they twinkle because of the turbulent atmosphere of our planet. The light from a star must pass through many layers of the atmosphere. Not every layer is equally dense, so this causes the light to slightly deflect and change in color and intensity. There's one star named Sirius that sometimes twinkles, sparkles, and flashes so much that some people even tend to report it as something extraterrestrial. This is because Sirius is very bright and is often low on the horizon, which means it experiences more of these special effects of the Earth's atmosphere. When in space, astronomers and astronauts who observe stars from there don't see them twinkling. Hey, want to hear something cool? Me, you, your friends, the rest of humanity, we're all made of stardust. The elements that make up human bodies and all life on Earth were formed inside stars. The building blocks of life, such as carbon, nitrogen, and oxygen, were created inside stars and were eventually released into space when the stars were gone. These elements then became part of new stars, planets, and eventually, life on Earth. The iron in our blood was created in the cores of supernovas, which are massive explosions that occur when stars fade. Some say that even the calcium in our teeth and bones is likely to come from exploding stars. The oxygen in our lungs was created in the cores of massive stars before being released into space through supernovas.
Now, I'll bet you remember the furthest planet from the Sun is Neptune. When European astronomers argued about what to call the newly discovered eighth planet back in 1846, they settled on the name of the Roman deity of the sea. This ice giant is 4 times the size of Earth. And if our planet was the size of a nickel, Neptune would be as large as a baseball. At the same time, the ice giant is 17 times as heavy. If you were approaching this icy world, it would seem blue and perhaps inviting. But this blue surface is actually a layer of swirling gas and permanent clouds. So don't get your hopes up. You wouldn't be able to land on this planet. Its mantle, made up of water, ammonium, and methane ice, is the closest thing Neptune has to a surface. But even down there isn't solid ground for you to walk on. Anyway, this distant planet is surrounded by mystery, and astronomers haven't cracked all of it yet. Why are the winds on Neptune so fast? Why does this world shed more heat than it gets? Why is its magnetic field offset? And what is the Great Dark Spot? Well, let's try to find some answers. Neptune is around 30 times as far from the Sun as our home planet. That explains why studying this distant world is so difficult. It also means that the planet gets way less light and heat from our star. But at the same time, Neptune radiates a lot more heat than it's taking. If we compare Neptune to nearby Uranus, we'll see that even though Uranus is closer to the Sun, it emits almost the same amount of heat as Neptune. Astronomers don't know for sure why it happens yet, but of course there are theories because they're scientists. Some experts believe there is something fierce inside the blue planet that causes it to generate more heat than it receives. It might be the reason for Neptune's huge differences in temperatures, from minus 260 degrees Fahrenheit at the planet's rigid cloud tops to more than 12,000 degrees at the core of the ice giant. So you're going to want to dress in layers. Now, such temperature variations might be the reason for powerful windstorms. Their speed can reach 1,200 miles per hour. For comparison, the most powerful winds on Earth move at a speed of 250 miles per hour. Another curious thing about Neptune's winds is that they are blowing westward, which is backward to the rotation of the planet. A study published in 2013 supposed that the winds on Neptune would appear in thin layers no more than 600 miles thick. Such a shallow depth might mean that condensing and evaporating moisture could produce those crazily fast air currents. Then there's the issue of Neptune's magnetic field being offset. If you were to overlay a magnet on this planet, it wouldn't line up with the center. Astronomers aren't sure why it happens. Magnetic fields are produced by moving currents, and all the planets, including Earth, are believed to have some conductive material moving in their bellies. But with Neptune's belly, it's a bit different. Its magnetic field is tilted at 47 degrees to the planet's rotation, which means that the rotation and magnetism aren't aligned inherently. And don't forget about the Great Dark Spot. No, I'm not talking about the most massive storm in the solar system. That one is called the Great Red Spot and is located on Jupiter. I mean a corresponding spot on Neptune discovered by Voyager 2 in 1989. In 1995, the Hubble Space Telescope turned its eye on Neptune. But, disappointingly, by that time, the spot had already mysteriously vanished, and scientists have no idea how exactly it disappeared. But guess what? Another dark spot has been found on the ice giant. Astronomers have known for quite some time that, from time to time, Neptune's surface gets dotted with such spots. These bizarre discolorations have been linked to high-pressure areas, coming and going over the course of a few years. But no one has seen a dark spot forming until recently. Since then, astronomers have been observing the birth of dark spots quite regularly. Now they have a much better idea of where and when these huge vortices might form. Now, despite assumptions, astronomers once thought Neptune was a boring, featureless world. The ice giant has a hyperactive atmosphere. It's turbulent, with cloud ripples and severe storms. Plus, this planet has a ring system. Disappointingly, those rings are not distinct hula hoops circling Neptune, like those of Saturn. The ice giant's rings are weirdly chunky and contain gobs of material that form arcs in the outer ring. Astronomers explain that these clumps are actually places where loads of ring particles are stuck together. What it means is still unclear. But my favorite thing about Neptune is this one. Astronomers believe that deep inside the planet, there might be a layer where it rains diamond crystals. Intense pressure and temperature inside Neptune break methane molecules apart, releasing carbon. These carbon compounds find their fellow molecules and create long chains, which then get squeezed together, forming beautiful crystalline patterns like diamonds. When these diamond formations drop through the layers of Neptune's mantle, it gets too hot for them. That's why they vaporize, float back, and, you guessed it, repeat the cycle. Now you know why it's called diamond rain. How about a fun little experiment? Let's say we exploded Neptune, in the name of science, of course. As you already know, this planet doesn't have a solid surface. That's why, after activating the process, you'd see Neptune's liquid mantle burst. It would look like a water-filled balloon thrown down from the 50th floor. Disclaimer, don't do this at home. The impact would send splashes of water, ammonia, and methane ice away into space. It'd be followed by lava-like remains of the planet's mantle, liquid and red-hot. And then there would be a hurricane of solid rocks. That's what would be left from Neptune's solid core made up of iron and other metals. Okay, let's put this pretty ice giant back together. I've got one more experiment for you. Let's replace the Moon, yes, our good old satellite, with Neptune. The ice giant is definitely way larger than the Moon. The planet would look like a bright blue hot air balloon in the sky, and we would see it not only at night but also during the day. It would appear to be 15 times larger than the Sun. If everything else remained the same, solar eclipses would seem to continue for ages. Once the Sun vanished behind Neptune's edge, our planet would be plunged into complete darkness for no less than an hour and a half. And since Neptune is also much more massive than Earth, its gravitational pull is much stronger. That's why, instead of getting itself a powerful companion and protector, our planet would end up as a satellite. Yep, Neptune's moon. It would orbit Neptune slightly further than its own largest moon, Triton, and there would be a great risk of Earth colliding with this space body. Uh-oh. But let's assume we were lucky enough not to cross paths with any of Neptune's satellites. Even so, we would have more than enough problems. Tides on our planet would be 1,000 times more powerful than those caused by the Moon. Neptune's gravitational force wouldn't pull Earth apart, but it would heat our planet up. Like we need more of that, huh? The seismic activity would increase, setting off earthquakes and volcanic eruptions. Well, that sounds unsettling. So let Neptune remain where it is now. I'm okay with a good old moon. Now we're done with the experiments, but hear me out. Beyond the orbit of Neptune, there's a mysterious Kuiper belt filled with massive icy objects. The most curious thing about this space formation, though, is that scientists fail to explain the pattern of its movement. The only explanation they have is that Neptune might be hiding another big planet from our sight. Are they in cahoots? This hypothetical planet has already got the name Planet 9, and all we have to do is wait until its existence is confirmed. Or not.
It was the year 2017 when astronomers spotted a bright star hurtling out of the Milky Way. It was moving incredibly fast at a speed of 2 million miles per hour. That's almost 4 times as fast as the Sun orbits around the center of our home Milky Way galaxy. It takes our star more than 225 million years to complete one journey. Anyway, back to our star, the Wanderer. The main issue with it was that it was moving against the direction in which most stars travel around the center of our galaxy. Even more bizarre, it consisted of totally different star stuff. Astronomers managed to identify its composition. The star was made up of heavy metallic atoms. At the same time, most of the other stars consist of way lighter elements. The wandering star got the name LP-40-365. It was moving so fast that it literally dashed out of our galaxy. This made scientists believe that the space traveler was pushed out of its place by some kind of cosmic disaster, like a supernova. A supernova is the largest explosion that can take place in space, an explosion of a star. It happens after irreversible changes start in the core of a star. Supernovas can occur in 2 ways, in binary star systems and when there's a single star. Binary stars are 2 stars orbiting around the same center. At some moment, one of the stars, a very dense white dwarf, starts stealing matter from its companion. After some time, this thief accumulates too much matter, which causes it to explode into a supernova. Or it can be a single star nearing the end of its life. It's running out of its fuel. More and more mass is flowing into the core of the star. In the end, the core becomes so heavy that it fails to withstand its own gravity. After the core collapses, a tremendous amount of energy is released in a supernova. But astronomers still can't figure out how a supernova could send LP-40-365 flying. There are more questions than answers. Was it a companion star that got flung out by a shockwave created by a supernova? Or was it a piece of the exploded star? A new study based on the collected data has shown that the star, which is a white dwarf, keeps slowly rotating around its axis. Astronomers are almost sure it means LP-40-365 is indeed just a chunk of space debris, and not a full-fledged star. This wandering piece somehow managed to survive one of the fiercest space events. But after making such a conclusion, scientists realize something amazing. LP-40-365's unusual features could appear after the star witnessed a supernova. Even though this event happened lightning fast, the entire makeup of the star got changed. Most stars consist mainly of helium and hydrogen, but LP-40-365 is different. It contains such heavy elements as magnesium, oxygen, and neon. It must have been the supernova that added these atoms to the star's composition. By the way, astronomers consider all elements that are heavier than helium to be metals. This means that after witnessing the supernova, LP-40-365 became metallic. Right now, the star doesn't have its own planets, but NASA's Transiting Exoplanet Survey satellite, which is on the lookout for distant planets passing in front of their host stars and dimming them, has noticed a curious thing. LP-40-365 brightens and then dims again every 8.9 hours. It might mean that the star pulsates, but usually, stellar pulsations are much less regular. A more plausible explanation is that the star's surface is uneven, and as it spins, sunspots are brought into and out of view. And it's great news, because after astronomers figure out how fast the star rotates, they can understand what happened to it around 5 million years ago during the supernova. Bright blue exoplanet HD 189733b looks peaceful and eerily familiar. Doesn't it resemble Earth? But this appearance conceals the planet's terrifying nature. There, the winds blow at 5,400 miles per hour. It's 7 times the speed of sound. But that's not the worst. It rains glass, sideways, in this scorching hot world. Neutron stars are ultra-dense collapsed cores of giant stars. They emit X-rays or radio waves. But in 2018, astronomers discovered a weird stream of infrared light. It seemed to be coming from a neutron star 800 light-years away from our planet. The most plausible theory is that this signal was probably produced by a disk of dust surrounding the star. But there isn't enough evidence to confirm this idea. Mercury is the fastest planet in the solar system. It zips around the sun at a breakneck speed of more than 100,000 miles per hour. That's around 40,000 miles per hour faster than our home planet. It's one of the reasons why a year on Mercury equals 88 days on Earth. Mercury is the planet that orbits the closest to the Sun. That's why if you were standing on its surface at its closest approach to our star, the Sun would look more than 3 times as large as it does on Earth. The Black Widow pulsar is a rotating neutron star that is munching on its partner, which is a lightweight brown dwarf star. The more material the pulsar consumes, the more slowly it spins. The energy the neutron star is losing in the process causes the companion star to dwindle. There's a stellar nursery in the constellation Centaurus, and even though this place is called a nursery, it's anything but peaceful or safe. It's made up of hydrogen and newborn stars and is located in a nebula around 6,500 light-years away from Earth. A nebula is a giant cloud of gas and dust floating in space. The intense energy baby stars emit makes hydrogen clouds glow ominous red. This energy is so powerful, it's eating away dark clouds of dust. Astronomers can see them disappear like lumps of butter on a hot frying pan. Faraway Neptune-sized exoplanet Gliese 436b is a paradox. It's made of scorching hot ice, and this ice is burning. The planet completes one full orbit around the red dwarf Gliese 436 in just 2 days. It means the exoplanet travels very close to its parent star. That might be the reason why the planet's temperatures rarely drop below 800 degrees Fahrenheit. But the strangest thing? The planet hosts huge volumes of water ice known as Ice X. And this ice remains solid despite such incredibly high temperatures. Jupiter is the largest planet in the solar system. It's 318 times as massive as Earth. It's also 2.5 times as massive as all other planets of the solar system combined. But here's a paradox. If this gas giant got even more massive, it actually becomes smaller. The added mass would make the planet denser, and this would cause it to start pulling in on itself. Astronomers claim that Jupiter can eventually end up being 4 times as massive as it is now. But at the same time, its size won't change. DGSAT-1 galaxy is as big as the Milky Way, but it's nearly invisible because its stars are spread out incredibly thin. But what makes the galaxy so unique is that it's sitting all alone, unlike other galaxies of this kind. Those are usually found in clusters. It can mean that DGSAT-1 was formed in a different era, probably a mere 1 billion years after the Big Bang. If it's true, the galaxy is a real living fossil. Saturn's moon, Hyperion, is one of the most bizarre-looking moons in the solar system. But the appearance isn't the strangest thing about this space body. The pumice stone-like rock is pockmarked with countless craters, and it's also charged with static electricity, which is flowing out into space. About 4,000 light-years away from Earth, there's a planet that seems to be one enormous diamond. The planet is denser than any other discovered so far and consists mostly of carbon. It's so dense that astronomers think this carbon might be crystalline. It means that at least some part of the planet is diamond. Ceres is the most massive space body in the asteroid belt between Jupiter and Mars. It totals almost a third of the entire mass of the whole belt. But at the same time, Ceres is the tiniest of the dwarf planets out there. It's also the only dwarf planet that dwells in the asteroid belt, and also the only one that is located in the inner solar system. Astronomers sometimes call Jupiter a failed star. The gas giant indeed contains a lot of helium and hydrogen. But its mass isn't enough to start a fusion reaction in its core. And that's exactly how stars produce energy. They fuse the atoms of hydrogen together under extreme pressure and heat and create helium. In the process, they also release light and heat. Jupiter could start a nuclear reaction and become a star only if it was 70 times its current mass. Space is completely, eerily silent. That's because in the vacuum of space, there's no atmosphere, and the sound waves need some medium to travel through. That's why worlds with atmospheres like Earth are full of noise. Unlike their massive siblings, hypothetical mini black holes could be really tiny, not bigger than an atom. Even so, just one minuscule thing would have enough mass of 1,000 sedans. One theory claims that tons of micro black holes could be created right after the Big Bang. Some scientists even go so far as to say that a couple of mini black holes pass through our planet every day. Every hour, the sun sends more energy to Earth than our planet uses in a year. Even though people are now using much more solar energy than a decade ago, it's still a mere 0.7% of the world's annual electricity usage. There might be moons orbiting other moons, but astronomers haven't agreed on this theory yet. Planets orbit stars, moons orbit planets. But why can't there be moons, also known as submoons, moonettes, and moons? Researchers claim that moons could exist, but the host moon has to be massive enough and the moon small enough. There must also be a large distance between these moons and the host planet. Jupiter is the most massive planet in the solar system. This means its gravity is also the most intense. It's 2.5 times as great as what we have on our home planet. Once, the gas giant's gravity even tore apart a large comet called Comet Shoemaker-Levy 9. Then the planet eagerly swallowed the chunks of the former comet. If you were standing at the equator on Mars, the temperature at your feet would feel like that of a warm spring day, but your head would be literally freezing. Lost in space and drifting through galaxies, rogue planets were once flung away from their parent stars, but one of them, floating 200 light-years away from Earth, is different from the rest. It's a planet-sized object with a magnetic field 200 times stronger than that of Jupiter. This field is so powerful that it generates never-ending flashing auroras in the planet's atmosphere. Europa is one of Jupiter's largest moons, even though it's smaller than Earth's moon. But the cool thing about this satellite of the gas giant is that it's covered with ice. And some of this ice is smooth, which means you could skate there. And a 3-foot axle jump you can perform on our planet would take you 22 feet into the air. At the same time, the landing speed on Europa would be the same as it is on Earth. Haumea, a dwarf planet orbiting the Kuiper Belt, has a bizarre elongated shape and 2 moons. The day on this planet lasts 4 hours, making it the fastest spinning large object in the solar system. But the most mysterious thing about Haumea is that the planet has a thin 40-mile-wide ring circling it. Astronomers haven't managed to figure out how or why it appeared around the dwarf planet. 11 Earths could fit across the equator of Jupiter, and if our planet was the size of a grape, the gas giant would be as large as a basketball. 9 spacecraft have already visited Jupiter. 7 of them just flew by, and 2 orbited the huge planet. The most recent of them, Juno, arrived at Jupiter in 2016. The craters of the moon's south pole are likely to be the frostiest place in the whole solar system. The crater's floors are always in the shadow. That's why the temperature never rises above 397 degrees Fahrenheit, even during the day. If you decided to fly a plane to Pluto, your journey would take around 800 years. You'll find the highest mountain in the solar system on an asteroid called Vesta. Its peak rises 14 miles above the base of the mountain. This makes Rhys Silvia, that's what the mountain is called, almost 3 times taller than Everest. Saturn's rings weren't discovered all at once. It happened gradually. That's why they were named alphabetically in the order scientists found them. Now they go like this: D, C, B, A, F, G, and E. A day on Venus is around 243 Earth days long, but the bad news is that you'd have to wait for a weekend for 3 years. All because a day on Venus is longer than its year. A solar phenomenon called terminator events is taking place at the Sun's equator. Disastrous magnetic field collisions seem to cause ginormous twin tsunamis of plasma. These tsunamis tear across the star's surface, moving at a speed of 1,000 feet per second. They can last for weeks at a time and happen almost every decade. The winds on Neptune are the fastest in our solar system. Most of them can reach the speed of 1,600 miles per hour. Almost any of these enormous storms could easily swallow our entire planet. The 18th brightest star in the night sky, Fomalhaut, is a terrifying sight. It's dubbed the Eye of Sauron because a ring of dust and debris circling it makes it look like a giant eye staring into your soul. The intimidating star is more than twice the mass of our Sun and is 25 light-years away from Earth, which isn't that far away considering distances in space. Mars has 2 moons, Phobos and Deimos. In the next 30 to 50 million years, the planet's gravitational forces will tear Phobos apart. It'll probably result in the formation of a ring around Mars. An asteroid the size of a car enters the atmosphere of our planet every year. Such an intruder could wipe out a small town off the face of the Earth. Dust and smoke would rise into the atmosphere, preventing sunlight from reaching the surface of the planet. It would cause the temperatures all over the world to drop and the climate would change. Luckily, such asteroids burn in the atmosphere before they even come close to the surface. The radio signal produced by a spacecraft when it contacts Earth is less powerful than a light bulb in your fridge. By the time this signal reaches our planet, its power is only 1/billionth of a watt. No wonder that antennas gathering these super weak signals are huge. The Deep Space Network that detects signals from spacecraft has dish antennas that measure up to 230 feet across. That's more than the width of a soccer field. In 1999, NASA lost a Mars orbiter because one engineering team was using the metric system, and another was doing calculations with the help of the imperial system. Nebulas are giant clouds of gas and dust. With time, gravity starts to pull these clumps of dust and gas together. They grow larger and larger. And their gravity gets more powerful. One day, a nebula's mass becomes so great that it collapses under its own gravity and forms a new star. Around 4,000 light-years away, in the constellation of Scorpion, there is the Butterfly Nebula. Its wingspan is greater than 3 light-years, and the structure inside the nebula is one of the most complicated ever observed. The nebula's central star, a white dwarf, is heated to an insane 450,000 degrees Fahrenheit. This means it was formed from another huge star, likely more than 5 times the size of our Sun. The white dwarf is surrounded by a thick disk of dust and gas at the equator. That's what probably makes the whole structure look like an hourglass, or a butterfly. If you decided to lump together all the known asteroids in the solar system, their total mass wouldn't exceed even 10% of the mass of our moon. A cloud of water vapor is floating in space. It surrounds a supermassive black hole 12 billion light-years away from Earth. The cloud contains 140 trillion times the entire volume of water on our planet. Astronomers think this water cloud appeared just 1.6 billion years later than the universe itself. The densest objects in space are neutron stars. They're the size of a small city, yet their mass is about 1.4 times the mass of our Sun. A single teaspoon of neutron star material would weigh 1 billion tons. and a neutron star's gravity is 2 billion times stronger than the gravity of our planet. In 1993, the Galileo probe was traveling past a miniature asteroid. It was no more than 20 miles across, and still, the tiny thing had a 1-mile wide moon. Astronomers have discovered tons of moons orbiting minor planets in the solar system since then. We live inside the Sun. The star's atmosphere stretches way beyond its visible surface, and our planet is well within its reach. That's how the gust of the solar wind creates such a breathtaking phenomenon as the northern and southern lights.
Imagine leaving your house one morning and seeing not one, but 2 stars shining in the sky. The first one is our good old Sun, and the other is Jupiter. But how has a planet turned into a star? And what will now happen to Earth and its inhabitants? Before we find the answer to these urgent questions, we need to revise some things we know about Jupiter. The largest planet in the solar system is a gas giant, which means it's made up mostly of gases. Due to the pressure and temperature differences, these gases separate into layers. This creates those red and white bands that can be clearly seen from Earth. The temperatures at the top of Jupiter's atmosphere are insane. They can reach a whopping 1,340 degrees Fahrenheit. The planet also has an immense gravitational pull. In 1995, the Galileo probe reached the atmosphere of Jupiter and sliced it at a speed of 106,000 miles per hour. It survived the scorching temperatures and started its descent. It kept moving even when the temperatures suddenly dropped and the pressure, as well as the speed of the wind, increased. But 58 minutes and 97 miles into its exploration, things went downhill. The pressure of 23 atmospheres and still high temperatures finished the probe off. It was melted and then vaporized by the extreme heat. Now, if Jupiter suddenly decided to keep growing, it would eventually become a star, and its composition would allow this planet to do it. Once, a long time ago, Jupiter took most of the mass that was left after the formation of our Sun. That's how it ended up with more than twice the combined material of all other bodies in the solar system. And the planet's ingredients are the same as those of a star, mostly hydrogen and helium. Jupiter is just not massive enough to ignite. But what if it was? Then it would turn into another kind of celestial body, most likely a brown dwarf. In this case, it would have a minor effect on the orbits of the planets of our solar system, because brown dwarfs are more massive than planets, but not as massive as stars. A brown dwarf is usually 13 to 80 times the mass of Jupiter. It can only become a star if the pressure in its core gets high enough to start nuclear fusion. So let's imagine that it's happened, and Jupiter has become a real star. For example, a red dwarf. Red dwarfs are stars with masses around 7.5% to 50% of the mass of our Sun. Red dwarfs are also hotter than brown dwarfs. Their temperature can reach 6,380 degrees Fahrenheit. Our Sun, by comparison, has a temperature of almost 10,000 degrees Fahrenheit. So, it means that the newly formed red dwarf will be far dimmer than the Sun. And still, red dwarf Jupiter could prevent the inner planets from following their orbits, because they wouldn't be able to find a balance between the gravitational forces of the two stars. The planets would move either closer to the Sun or closer to the newly formed red dwarf. If Earth chose the first option, our main star's insane temperatures would probably wipe all living beings off the face of the Earth in no time. If it was the second scenario, we'd probably freeze, since Jupiter, as a dim red dwarf, wouldn't be able to warm us up well enough. But there could be one more option. The inner planets could get thrown out of the solar system altogether. If Jupiter was a star, it would also greatly increase the amount of radiation the surface of Earth would receive. Our atmosphere would have to protect us both from the radiation coming from the Sun and from Jupiter's radiation. Red dwarfs are notoriously active. That's why Jupiter, just like the Sun, would most likely have frequent coronal mass ejections. This is a fancy expression for describing large clouds of electrically charged particles a star releases with a huge burst of speed. Even now, Jupiter has a significant impact on our planet. The gas giant is roughly 318 times as massive as Earth, and this also means it has an outsized pull on our planet. Its gravity can cause shifts in the orbit of our planet and climate swings every 400,000 years or so. When Jupiter's influence is the strongest, Earth usually has colder winters, hotter summers, and more intense periods of wetness and droughts. Also, if Jupiter turned into a red dwarf, its most prominent feature might probably disappear for good. I'm talking about the Great Red Spot. It's an enormous storm raging in the southern hemisphere of the gas giant. Its top parts tower more than 5 miles above the tops of the surrounding clouds. The storm is almost twice as wide as our planet. In 2017, NASA's Juno space probe managed to collect lots of data about the red spot, and it turned out that this monster of a storm went more than 200 miles down into the planet's atmosphere. That's 30 to 100 times deeper than any ocean on Earth. But these measurements are most likely imprecise, and the storm's true roots can be reaching even deeper. The Great Red Spot is colder than the rest of the atmosphere, and keep in mind that Jupiter's temperatures are negative 280 degrees Fahrenheit in the upper cloud layers. On the other hand, the closer to the core, the hotter it gets. Mysteriously, the highest temperatures ever recorded on the gas giant occurred in the atmosphere right above the Great Red Spot. They were higher than the temperature of lava on our planet. Astronomers believe that the turbulence caused by the storm might produce gravitational and sound waves that can be responsible for the superheating. But the storm itself is warmer at the bottom than at the top. People have been watching the moving vortex on Jupiter for more than 150 years. Some time ago, astronomers predicted that it would gradually slow down and become smaller or disappear altogether. But that turned out not to be the case. After having analyzed all the data received with the help of the Hubble Space Telescope, researchers were baffled to discover that the winds at the outer boundaries of the storm had actually picked up speed. The wind speed at the edges of the storm can reach a mind-boggling 400 miles per hour. That's faster than Earth's tornadoes. At the same time, if you found yourself at the center of the Great Red Spot, you wouldn't be too impressed. The winds there move way more slowly. And now, I have another what-if situation for you. What if Jupiter collided with the smallest star we know about? Today, these two space bodies are on a collision course. A spoiler, Earth might not survive such an encounter. Okay, meet this tiny red dwarf. It's the size of Saturn, and its gravity is around 300 times the gravity of our planet. It normally floats 600 light-years away from Earth in a double star system. But today, for some inexplicable reason, it's broken all the laws of the universe and is rushing toward the biggest gas giant in our solar system. And even though this space guest is smaller than Jupiter, its mass is way greater, and its gravitational force soon starts to pull on the gas giant. The heat from the red dwarf, plus its powerful gravity, makes Jupiter grow in size. The planet's atmosphere starts to puff up because the gases that make up the planet begin to heat up and expand. Jupiter's atmosphere starts to leak into space toward the stellar visitor. Sometime later, the runaway gases form a bright hot ring around the red dwarf. This is a terrifying view, as if a black hole, a very bright one, has appeared inside the solar system. The star keeps tearing Jupiter apart, eating chunks of the gas giant, and soon the red dwarf engulfs it completely. Sadly, Jupiter never stood a chance. Instead of the gas giant, we now have a red dwarf surrounded by a ring of hot gases. And we already know how badly it may end. The best thing about it is that this scenario is totally imaginary. Phew, thank goodness.
What would the Earth look like if it was born in another solar system? I did a little research for you to find out, and the results were surprisingly wholesome. There are some warm tropics, strong winds, and giant dragonflies. But okay, let me explain from the very beginning. Since 1995, NASA has discovered more than 4,100 planets outside the solar system. Unfortunately, most of them are either flying ice balls like Neptune or gas giants like Jupiter. But there are still as many as 161 planets similar to our Earth. And one of them is very close to us, in the Alpha Centauri constellation. There are 3 stars in this constellation. 2 of them are called Alpha Centauri A and Alpha Centauri B. If you live in the southern hemisphere, you've probably seen them. They're very bright. Because of that, they look like one big star. They rotate around each other very slowly. And there's the 3rd star, chilling around not far from them. It's a teeny tiny red dwarf, Proxima Centauri. It got its name because of its proximity to our Sun. This star is the most interesting one, so let's talk more about it. Proxima Centauri is only 4.5 light-years away from us. Oh, and 1 light-year is about 6 trillion miles. Yep. If we went there, it would have taken just a little over 165,000 years of traveling in a space shuttle. Oh, you think that's a lot? For the universe, it's like checking on your fridge. Proxima Centauri is much lighter and much smaller than the Sun. It's also 2 times colder than the Sun, with a temperature of 3,000 Kelvin. That's why we can't see it without a telescope. On the bright side though, it will burn for trillions of years, and you don't have to worry that one day it will eat us like our Sun. And yes, our twin planet is located right next to Proxima Centauri. This planet is called Proxima b. Yeah, I know, they got creative with all these names. I hope you won't get confused. It's slightly larger and more massive than the Earth. This planet is located in the habitable zone of Proxima Centauri. It means that there can be water and even some microorganisms there. Yes, it's possible that one day we'll find some life there. But right now, we don't know much about this mysterious planet. It's probably a rocky planet like our Earth and has a similar landscape, but this is just a theory. Who knows what kind of jokes the universe can throw at us? It would be a shame to fly 165,000 years just to stumble upon a giant piece of ice or something. Fortunately, we probably don't have to wait that long. The big brains are now developing a technology that would allow us to move at the speed close to the speed of light. If they succeed, we'll get to Proxima b in just 20 years. But anyway, this video is not just about Proxima b. It's about what would have happened if life had originated not in our solar system, but in Alpha Centauri. What if we were orbiting Proxima Centauri, or the other 2 stars? So now, let's imagine that the Earth has replaced Proxima b. I'm going to call this new planet New Earth. Guess I'm not very creative at naming either. First of all, the orbit. The new Earth must be about 25 times closer to its star than Proxima b is. Otherwise, it would be unimaginably cold. Let's move the planet a little closer. Excellent. The day still lasts 24 hours, but our orbital period is very high. Proxima b revolves around its star in 11 days. But we'll make it in just 8. Hey, a birthday party every week? Sign me up. Oh, hold on. There's another problem. You see, Proxima Centauri is a flare star. This means that sometimes, just out of nowhere, it throws out some stellar winds. These winds carry around a bunch of ionized particles, which then settle on the planets. Yeah, our Sun also does that, but Proxima Centauri tries to finish us off 2,000 times harder than our Sun, so the radiation levels are off the scale, to say the least. Don't worry, it's fine. All we need are incredibly strong magnetic fields. They will help us create a very thick atmosphere that can protect us from the Proxima Centauri's tantrums. So now it's going to be very warm. Or not. Another problem. Scientists are still not sure how exactly Proxima Centauri's planets rotate around it. What if they turn out to be tidally locked, like our Moon? Then one half of the new Earth will be a frying pan, and the other half will be some frosty deserts. Oh, it's fine, we'll just settle down somewhere in the middle. Didn't expect that I would ever say this, but it will definitely be warm at the North Pole. And if we're lucky with the rotation, we'll just get a cozy, warm planet. The average temperature is about 70 degrees Fahrenheit, and there aren't any extreme temperatures. On the new Earth, we have much more water. The weather is generally pretty crazy, some very strong winds and quite destructive rains that can go on for quite a long time, but you can adapt. Temperature changes are much more noticeable in the mountains. Just like on Earth, the higher you climb, the colder it gets, except it's very cold right here at the top. Because of this, the mountains and hills have jungles below and snow-covered deserts on the tops. But in general, it's almost like the Earth's tropics. The flora is very rich, the trees are very low but lush. The thick atmosphere also makes flying easier, so there are a lot of large flying animals, like dragonflies with a wingspan of 16 feet. Moving on. The sky here is much lighter than that on Earth and very cloudy. Sometimes it may seem completely white. But the starry night is beautiful and bright. There are 4 suns. Our main one is Proxima Centauri. We can also see 2 bright Alpha Centauri stars. And finally, our old sun, which looks like a bright, distant star. I'll allow you to shed a tear for the old Earth. There's a few planets near us, like Proxima Centauri c. The host star is surrounded by 2 belts of cosmic dust, so get ready for some gorgeous, colorful night views. So what we have in the end is a little crazy, but a beautiful green planet. I personally wouldn't mind moving there already. What about you? Write in the comments. Alright, so now we know what would have happened if our Earth had been born near Proxima Centauri. What about the other 2 stars? Unfortunately, we won't be able to rotate near 2 stars at the same time. Scientists suspect that Alpha Centauri A and B have some kind of common planet that jumps from one orbit to another, but it's probably very cold. Let's choose Alpha Centauri A. Just like on the new Earth, here our average temperatures are about 70 degrees Fahrenheit, but now the temperature variation is quite large. It goes from -100 degrees Fahrenheit at the South Pole to 113 degrees Fahrenheit at the equator. We'll be fine close to the north. The day is still 24 hours, and the orbital period is 1 year and 1 month. It's almost the same for the Alpha Centauri B, but the orbital period is about half a year. Other conditions are very similar to those on Earth. Changes in the seasons are almost not noticeable. The temperatures don't change much either. No matter where we settle down, the neighboring star will be clearly visible, but we probably won't see Proxima Centauri. And that's about it. Of course, all this assumes perfect conditions. Just like on Earth, one slightest change, whether it's a thin atmosphere or a bigger distance from the star, and it won't end well. We got really lucky with our Earth. But even so, the chances of finding a habitable planet are very high. Even with the tiniest possibility, there will be about 15 million planets in our universe that we can find life on. Space, the final frontier. It's a vast and mysterious expanse that has fascinated us for centuries. But as much as we've learned about it, there are still plenty of things that we've been lied to about when it comes to space. Let's take a look at some of the biggest lies we've been told about this topic. First off, we have the idea that space is just this pristine, untouched wilderness. But that's not exactly true. We've been littering space with our debris for decades. Everything from old satellites to rocket parts. In fact, there are over 20,000 pieces of debris orbiting Earth right now, and they're causing all sorts of problems for future space missions. So if you're planning on visiting space anytime soon, watch where you go. You never know what kind of garbage might be floating around. Did you know that the sun is not actually yellow? It's green. Well, kind of. You see, scientists measure the temperature of a star by the color spectrum it emits. Cooler stars appear red, while the hottest of stars look blue. Our sun emits most of its energy at a wavelength that's close to green. But because it emits other wavelengths too, all these colors mix together, and your eyes see this vibrant mixture as white. From Earth, however, the sun looks yellow because our atmosphere is really good at scattering blue light. If our star was actually yellow, Earth would become a frozen rock, and we'd all be polar bears. Plus, the sun isn't on fire for real. It's a big ball of gas, mostly made of hydrogen and helium, and it works more like a gigantic nuclear reactor, constantly fusing hydrogen atoms to create helium inside its core. This process releases enormous amounts of energy. That's why the sun is so hot. Oh, and speaking of setting things on fire, explosions in space aren't real. Sorry, Star Wars fans, a spaceship can't go down in a violent blast because there is no air out there in space. No air means no oxygen, and no oxygen means no fire. Now, you might also think that there are too many stars in the night sky for you to count, but in fact, you can do that. According to the Yale Bright Star Catalog, there are 9,110 stars that you can see from Earth with the unaided eye. So, technically, you can count them, but I wouldn't be surprised if you lost count. And if you're worried about flying through an asteroid belt, don't be. Although it does have trillions of space rocks that range in size from space dust to a quarter of the size of the Moon, they're very spread out. The asteroid belt between Mars and Jupiter is 140 million miles across, which is 1.5 times the distance between Earth and the Sun. This spreads space rocks thousands of miles apart, making it almost impossible for a spacecraft to collide with one. You'll instantly freeze in space without a suit. Nope, you won't turn into a popsicle right away. It's going to take a bit longer than that because heat and cold don't really move very quickly in the vacuum of space. But unfortunately for you, there's a bigger problem at hand. You won't be able to breathe. After just 15 seconds, your brain won't be getting enough oxygen from your blood, and you'll pass out. And then after just 2 minutes, it's curtains for the rest of your organs. So, in short, if you find yourself playing astronaut without a spacesuit, it's game over pretty quickly. Did you know that space doesn't have any temperature at all? That's because the temperature is defined by the speed at which particles move and the amount of energy they have. In the true vacuum of space, there are no particles to move around, making it temperatureless. Of course, some parts of space are really hot, like areas around stars. But the further away you get from stars, the more spread out particles are, making those areas of space pretty chilly. Number 9 is our planet's shape. No, it's not flat, but it's not a perfect sphere either. Yeah, it bulges at the equator because of our planet's wild spin. It's like Earth is doing its own little dance. And because of this bulging, launching spaceships from the equator is much easier than from the poles. Now, when it comes to sound in space, it's a bit of a tricky situation. You might think that no one can hear you scream, but that's not entirely accurate. The thing is, sound needs something to travel through, like air or water. In space, things are super spread out, so all those epic space battles and galactic explosions would be completely silent. Yet there are some places in space with enough particles for sound to travel through. For example, you can hear the black hole at the center of the Perseus galaxy cluster. Another myth is about zero gravity. That's not a thing. There's still some gravity hanging around the International Space Station, about 90% of what we feel on good old Earth. But astronauts get to float around because they're basically free-falling around the planet. And let's be real, Hollywood's version of space travel is not factual. Sure, orbits are a thing, but different altitudes mean different speeds. So moving from one orbit to another isn't exactly a walk in the park. You can't just push yourself in the right direction and hope for the best. You gotta take those orbital velocities into account. This reminded me of the 2013 movie Gravity and how Sandra Bullock tried to survive in space. Hollywood sure added some fuel to these myths. Yet again, who can blame them? Back in 1976, NASA's Viking 1 spacecraft snapped a photo of a curious rock formation on Mars that looked suspiciously like a face. Some folks out there claimed that it must have been proof of extraterrestrial life on the red planet, but NASA had a different take. According to the space agency, the face was nothing more than a bunch of rocks piled up in such a way that the shadows they cast created an illusion of facial features. It turns out it was just a regular hill that got a little too much credit for being photogenic. The solar system stays in place. Lie! It's zooming through space at a speed of 140 miles per second, which means that it's whizzing through the cosmos faster than a cheetah chasing its prey. It takes us 230 million years for the solar system to complete a full orbit around the Milky Way. It's a good thing it isn't getting a speeding ticket, because that would be one astronomical fine. Eh? Without the sun, planets would be pretty chilly. We're talking about temperatures as low as -455 degrees Fahrenheit. Brrr. But with the sun around, the planets get to enjoy much more livable temperatures. Of course, not all planets are created equal. Mercury, for example, is the closest to the sun. Venus, on the other hand, is farther away, but somehow manages to be even hotter than Mercury. The distance from the sun isn't the only factor that affects a planet's temperature. Other things like the planet's size and reflectivity also come into play. So Mercury being the hottest planet in our solar system is a false proposition. No, just because it's the closest one to the sun doesn't mean it's the hottest. Even though we've been deceived in some ways, that doesn't make space any less amazing. It's still a vast, beautiful, and utterly fascinating part of our universe. And there's still so much we have yet to discover. Who knows? Maybe one day we'll really discover little green people out there. Or maybe we'll find out something even more incredible. Until then, we'll just have to keep dreaming and exploring. There, you got 14 things on our list. Do you have any other space myths to debunk?
Beetlejuice, a red supergiant. This ball of boiling plasma is one of the largest stars in our galaxy and one of the brightest. It's about 500 times larger than the Sun. But Beetlejuice is pulsating, getting bigger and smaller. At its peak, it becomes 800 times its average size. If this star were a bucket, it would fit about 300 million suns, even though its weight is only 17 times greater. And here, about 500 light-years away, is Earth. We launch our faster-than-light spaceship and set off on our journey to Beetlejuice. A few seconds, and we've already traveled 240,000 miles, and now are close to the Moon. That's 9.5 trips around the Earth. A traditional rocket-powered spacecraft would take 3 days to get here. We're near Mars now. The flight to the red planet usually takes about 7 months. Several rovers are now at work here, as well as the first ever flying drone, Ingenuity. The surface of Mars is 3 times smaller than that of Earth. The planet is also 10 times lighter. People hope to build a human colony here soon. Right beyond Mars, we have to wiggle and constantly dodge space rocks. This is the asteroid belt. It contains debris and space objects of different sizes and shapes. The biggest of them is Ceres. Its surface is slightly larger than the area of Argentina, and its weight is about 1% of the Moon's. The total weight of the entire asteroid belt is 25 times less than the Moon's. Next, we pass gas giants Jupiter and Saturn. These are the largest planets in the solar system. They're also the heaviest, even though they don't have a solid surface. Then, we travel by Uranus and Neptune. They're called ice giants. And at the very edge of the solar system, we see Pluto. It was once considered a full-fledged planet, but now it's not even on the list. After that, we're 4.3 billion miles away from our home. It took the New Horizons space probe about 9 years to get here. Hold on to your seat, we're speeding up! We're passing through the Kuiper Belt. There are lots of asteroids and blocks of ice here. These are some of the oldest building materials in our solar system. Billions of years ago, our whole world looked like a cloud of these asteroids. We're traveling further through dark space and reach the edge of the solar system, the heliosphere. All this time, we've been moving with the solar wind, but now it starts to slow down, collides with the interstellar wind and heats up. This is called the termination shock. The Voyager 1 space probe got to this point in December 2004. We're moving to the region where the heliosphere ends and interstellar space begins. This is the heliopause. In 2012, Voyager crossed this boundary and became the first ever human-made object in interstellar space. But the message from Voyager reporting this event came to Earth almost a year later because of the huge distance. It took 35 years for Voyager 1 to travel all this way. And here it is. The probe is as long as a car and weighs like 2 motorcycles. You can see a gold plate on its hull. It's a message from people to potential civilizations out there. It has pictures of Earth's landscapes, recordings of human speech, and our DNA. As of 2021, Voyager has been operational for almost 43 years. The probe has traveled 14 billion miles. That's like 152 Earth to the Sun distances. And it's still making its way through space at 38,000 miles per hour. Now, we're approaching the nearest star to our solar system. It's Proxima Centauri. We're so far from home that even light needs more than 4 years to travel this distance. If we used a traditional rocket, the trip would take us 73,000 years. The reason we wanted to get here was because of an Earth-like planet called Proxima Centauri b. It's 10% larger than Earth and slightly heavier. It lies in the habitable zone of its host star. It means that water might exist on the planet in its liquid state, and there can be life that forms here. But the star itself occasionally produces flares. Recently, its brightness increased almost 1,000 times. During that time, it emitted so much radiation that even if there were some forms of life on the planet, they probably ceased to exist. We're now more than 8 light years away from Earth. The brightest star in our night sky is Sirius. Seriously. It's so bright that you can see it even during the day. But in reality, there are actually 2 stars, Sirius A and B. They orbit around a common center of gravity, and these stars are moving toward our solar system at almost 5 miles per second. That's the same as the maximum speed of a top-of-the-line supercar on Earth. Foot down, and we've arrived at a potentially habitable planet 39 light-years away from Earth. This is TRAPPIST-1d. Its host star is a white dwarf. It's a cold star, 10 times smaller and lighter than the Sun. There are 7 planets around it, but TRAPPIST-1d is the most similar to Earth. It's only 30% smaller and 3 times lighter, but it has a rocky surface and the temperature here is 48 degrees Fahrenheit. You'd feel comfortable here wearing a light jacket. There might be an atmosphere, mountains, seas, and oceans here, which means this planet might be suitable for a human colony. But it would take about 677,000 years to get here using traditional rockets. And here's our main goal, Beetlejuice. It'd take nearly 8.7 million years to travel here from Earth in a current-day spacecraft. This star is so big that our ship looks like a grain of sand on a giant beach. We have to jump back in time to find out what happened to this star. First, there was a beautiful nebula. It's a cloud of multicolored space dust and debris. Then, it began to shrink under its own weight. In the core of the nebula, a nuclear reaction began. Boom! And the star was born. At first, Beetlejuice was very massive and hot, but it didn't expand and remained stable. Let's look into its heart. The nuclear reactions in the star's core create a lot of heat and energy. This energy produces the force that pushes on the walls of the star from the inside and causes it to expand. But at the same time, the star is very heavy. That's why gravity pushes on it from the outside. If these 2 forces are balanced, the star remains stable. But over time, the star runs out of its fuel, helium and hydrogen. That's when heavier elements in the core join the nuclear reaction. When they burn, they release more energy and heat than gravity can hold, and the star starts expanding. That's what's happening to Beetlejuice right now. It's already so big that if you put it in the center of our solar system, its edge would touch the asteroid belt between Mars and Jupiter. Beetlejuice will continue to expand until it exhausts its fuel completely. Then the gravity will win. The star will shrink in size, and then an enormous boom will happen. A supernova explosion will be so blinding that Beetlejuice will shine brighter than the moon in the night sky. Luckily, Earth is too far away for this explosion to cause any harm to people. A strong stream of matter that will be ejected from the explosion site won't reach the solar system until 6 million years later. Even so, the solar wind will stop this flow, so we'll be safe. Beetlejuice is likely to explode at any time in the next 10,000 years, but some scientists say it won't happen in the next 100 millennia. Back to the moment before the explosion of Beetlejuice, there can be another, more interesting scenario. Gravity might compress the massive core of the star with such force that a black hole will appear in its place. Black holes are the heaviest objects in the universe. They have incredible gravitational force. Even light can't escape their gravitational trap. The Beetlejuice black hole will begin feeding on cosmic dust and whatever is left of the star. All this debris and light from other stars will get frozen near the event horizon of the growing black hole. For the first time in history, we'll be able to watch the birth of this mysterious object. But in reality, Beetlejuice is too light to become a black hole. Most likely, after the explosion, it'll turn into a white dwarf that will gradually fade until it becomes invisible.
Earth's magnetic field hides a fascinating story. It turns out that it's getting weaker day by day. In fact, it's been doing so for the last 3,000 years. And if this trend continues, we could be in for some trouble within a millennium. What's the big deal? Well, picture this. Magnetic north becomes south, and vice versa. Pretty wild, right? When this happens, our planet's protective magnetic shield might weaken, allowing more cosmic rays to hit us. These high-energy particles from the universe can cause electronic malfunctions in our satellites and produce elements that could be harmful to us. The last time a polarity reversal occurred was between 772,000 and 774,000 years ago. Thankfully, humanity has some pretty smart people on the case who are investigating the history of Earth's magnetic field. They take cores of sediments from the seafloor and study the magnetization of fossils to figure out when these reversals occurred in the past and when they might happen again. Another group of researchers is studying the South Atlantic anomaly, SAA, a vast region of Earth's magnetic field that is about 3 times weaker than the field at the poles. Using data from multiple satellites, they are trying to figure out what's causing the SAA and how it might change in the future. This could give us a glimpse into how a weakened magnetic field can affect our satellites and our planet. Sure, our generation won't be here to witness these changes, but it does make you wonder what that planet might look like upside down. Magnetically, that is. NASA's astronomers have also announced that in 4 billion years, the Milky Way galaxy is going to get a major glow-up. After a cosmic collision that will shake things up. I'm not talking about a small fender bender here. I'm talking about a titanic collision with our neighboring Andromeda galaxy. Humanity will have to hold on to its space helmet for this one, because the sun might get flung into a new region of the galaxy. However, our Earth and solar system probably won't be seriously affected. Sounds difficult to believe, so how come? NASA's Hubble Space Telescope did some hardcore measurements of Andromeda's motion. Although the galaxies will plow into each other, the stars inside each galaxy are so far apart that they won't collide with other stars during the encounter. However, the stars will be thrown into different orbits around their new galactic centers. According to simulations, our solar system will probably be tossed much farther from the galactic core than it is today. Set your telescopes aside. You don't need to start counting down the years. This event is likely scheduled in about 4 billion years, so chances for us to witness it are 0. Saturn is losing its rings. Thankfully, we won't be here to witness this sad event either. Apparently, the rings are being pulled into Saturn as a dusty rain of ice particles, all under the influence of Saturn's magnetic field. According to NASA's research, the ring rain is draining an amount of water products that could fill an Olympic-sized swimming pool from Saturn's rings every half an hour. The entire ring system will likely be gone in 300 million years. Scientists believe we should consider ourselves lucky to witness Saturn's ring system at all, as it seems to be in the middle of its lifetime. But if you think about it that way, that rings around planets are all temporary, there's a chance we've just missed out on the giant ring system of Jupiter, or those of Uranus and Neptune. These planets have only thin ringlets around them these days. Scientists have long debated whether Saturn was formed together with its rings or if the planet acquired them later in life. The new research favors the second scenario, indicating that they are unlikely to be older than 100 million years, while Saturn itself is around 4.5 billion years old. What caused the rings to appear in the first place? Well, there are a few theories. One of them suggests the rings could have formed when small, icy moons in orbit around Saturn collided. Perhaps their own orbits were messed up by a gravitational tug from a passing asteroid or comet. Who knows what humans might end up looking like in the future? It's unlikely we'll see any major changes in our lifetime. But let's take a journey to the future and ponder what we might evolve into. Will we become cyborgs with all sorts of cool machine implants? Or maybe we'll become a hybrid species of biological and artificial beings. To understand our future evolution, we gotta take a peek at our past. 1 million years ago, Homo sapiens didn't even exist. There were a few other similar species though, like the Neanderthal. Fast forward to today, and humans have become taller and sturdier. Maybe in the future we'll become smaller to conserve energy, as it's predicted that our planet will get more crowded. Speaking of crowded planets, living in these new conditions means we have to adapt, and fast. We're constantly interacting with lots of people, and remembering names is becoming a crucial skill. Luckily, technology might help us out with brain implants that will improve our memory. In the future, we might also have more noticeable technologies as part of our appearance. Imagine having an artificial eye with a camera that can read different frequencies of light. While predicting 1 million years into the future is pure speculation, we can use bioinformatics to make some predictions about the immediate future. Demographic trends suggest that urban areas will become more genetically diverse, while rural areas will become less diverse. And what about space? If we end up colonizing Mars, our bodies could change due to lower gravity. Maybe we'll have longer arms and legs, or even insulating body hair like our Neanderthal cousins. In the future, our moon is also going to witness some dramatic changes. We'll miss these ones too. In about 5 billion years, things are going to get really interesting in this corner of the universe. For now, the sun is chilling in its main sequence phase, just burning hydrogen like nobody's business. In the future, during the red giant phase, the sun is gonna puff up like a balloon until its atmosphere reaches out and engulfs our beloved Earth and Moon. Our natural satellite, which is already moving away from Earth, is gonna get warped around the sun's influence. Its orbit will get all wonky, and it'll end up closer to Earth during the new moon phase than during the full moon. And that's not even the worst part. If left alone, the moon would keep on moving away from Earth until it'll need almost 50 days to orbit us. As the sun continues with its own journey, its atmosphere will drag on the moon and cause its orbit to decay. Eventually, the moon will get torn apart into a stunning ring of debris circling Earth. We're talking about all its mountains, craters, and even the footprints and flags we left there, all scattered throughout the debris field. There's a chance the sun will shed enough mass to spare Earth and the moon from total annihilation. Or if we're really lucky, the sun will lose 20% of its mass and we'll be safe and sound. It's all just theory right now. We haven't seen a red giant star during this phase. The universe itself might go completely dark one day too. Scientists can't predict it with absolute certainty, but they can make some educated guesses. Right now, our universe is 13.77 billion years old, and it's still churning out new stars left and right. It's said that eventually, after about 1 trillion years, the last star will be born. That final star will be a little guy, a red dwarf, just a fraction the size of our sun. These stars are champs at living long lives, slowly sipping on hydrogen to keep their fusion reactions going. But even they can't last forever. Fast forward about 100 trillion years, and the last light will go out. The universe will be dark and lonely, but thankfully, we won't be here to watch it all fade away.
Now, I don't want to freak you out, but something bizarre has erupted in the depths of space. It was an explosion brighter than billions of suns. But the real mystery is that it doesn't match anything astronomers have ever seen. Usually, cosmic events like this follow familiar patterns, but not this one. It's a cosmic anomaly. This strange cosmic explosion has left astronomers totally baffled. It could be a super rare event where everything lines up just right, or it could be something completely new, never seen before. This event was first detected by an X-ray space telescope called the Einstein probe on April 8, 2024. It first appeared to be a regular gamma-ray burst. Those typically give off incredibly bright X-rays. But could the answer really be so simple? Something didn't add up. Now, gamma-ray bursts are the most powerful explosions in the universe, and they can happen in unusual ways. Long-duration gamma-ray bursts are caused by the demise of massive stars that spin incredibly quickly. When these stars run out of fuel, their cores collapse under gravity, forming an extremely dense object, like a black hole. At the same time, the outer layers of the star are blown away in a massive explosion called a supernova. Gamma-ray bursts are followed by jets. Those are twin beams of material shooting out from opposite sides of the collapsing object. They're super fast, moving at nearly the speed of light. These jets appear brighter if they're pointed directly at us. It's like how a flashlight beam is brightest when it's aimed straight at you rather than at an angle. Now back to our unusual cosmic explosion. Remember me telling you something wasn't adding up? Hey, it was just 45 seconds ago. Well, the problem was that when multiple telescopes observed this event in different wavelengths – ultraviolet, optical, near-infrared, radio, X-rays, gamma rays, you name it – it didn't match any known type of event. The most likely explanation, according to current research, is that this explosion is the result of a white dwarf star being torn apart by a medium-sized black hole. And still, it's not so simple. Now, black holes are areas in space where gravity is so strong that nothing, not even light, can escape. That's why they're called black holes. It's believed that stars with at least 3 times the mass of our Sun can collapse under their own gravity once they run out of their stellar fuel. When a star has so much mass packed into such a small space, its gravity becomes so powerful that it forces everything, including atoms, to squish together. This intense density leads to the formation of a black hole. So, when a white dwarf star is torn apart by a medium-sized black hole, it results in a high-speed jet of material that can be aimed directly at Earth. So, could this space disaster be the reason behind our mysterious event? Unfortunately, even though it ticks some boxes for several types of phenomena, including the one involving a white dwarf, it still doesn't fit all the criteria for any of them. The event's short duration and high luminosity are hard to explain using any scenarios we can produce. So, does it mean we have come across something completely new? The universe is full of energetic flashes caused by outbursts from stars and black holes, supernova explosions, stars being eaten by black holes, and other cosmic events. Astronomers usually figure out what these events are by analyzing their duration, frequency, source, and the specific combination of wavelengths they emit. Here, I just have to say a few words about the instrument that discovered the space anomaly. The Einstein probe is an X-ray space telescope project led by the Chinese Academy of Science in collaboration with the European Space Agency and the Max Planck Institute for Extraterrestrial Physics. That's a mouthful. This project is all about studying high-energy space events over time. Its main goal is to find inactive black holes and figure out how matter falls into them by spotting X-ray flares produced by these sudden space events. The Einstein probe also hopes to catch the electromagnetic signals from events that cause gravitational waves, like when neutron stars merge. It also keeps an eye on the whole sky to spot all kinds of space explosions and track already known changing X-ray sources. After the Einstein probe detected that ultra-bright space flash, the event was also observed by a few other ground-based and space telescopes, including the Nuclear Spectroscopic Telescope Array, SWIFT, Gemini, Keck, Dark Energy Camera, Very Large Array, Australia Telescope Compact Array, and Neutron Star Interior Composition Explorer. That's a bigger mouthful. Using all this data, astronomers pieced together the event's characteristics, but it didn't make the case any clearer. Quite the opposite. It just deepened the mystery. This event flared up in soft X-rays for the first 10 seconds, then plateaued at a steady glow for about 4 days before fading quickly within another day. This is much longer than typical gamma-ray bursts, which usually last from a few milliseconds to several hours. But it was still not long enough to fit into other known categories. The event's brightness in X-rays was also unusual. It was too bright for some types of phenomenon, but not bright enough for others. The most puzzling part is that the Very Large Array didn't detect any radio emission from the source when it was observed 11 days, 158 days, and 258 days after the initial flare. Now normally, when something this bright in X-rays lasts for this long, it's usually associated with a luminous radio counterpart. But in this case, no radio signals were detected, which is very strange and adds to the mystery. Astronomers didn't give up and considered several other possibilities, like fast blue optical transients. Those are a new class of explosions that release huge amounts of energy and blast matter into space at incredibly high speeds. These bursts are so powerful that one F-bot can be at least 10 times more powerful than a regular supernova. Fast blue optical transients do look like supernova explosions, but they are much faster. They flare up and fade away much more quickly than regular supernova. They're also much hotter, which makes the light seem bluer compared to other supernova. Since these explosions happen so quickly, it's tough to figure out what causes them. In January 2019, astronomers narrowed it down to 2 causes: a black hole consuming a white dwarf star, or a rare kind of supernova that leads to the formation of a neutron star or a black hole. Now, another explanation for our mysterious space explosion, and astronomers think it's the most likely one, is a tidal disruption event. It happens when a black hole swallows a star, causing a flash of light. When a star gets too close to a supermassive black hole, it doesn't get off easily. No, the black hole's powerful tidal forces tear the star apart, breaking it into pieces and pulling it toward the black hole. Its remains turn into a stream of debris that falls toward the black hole's accretion disk. However, before the debris settles into the disk, it overshoots the black hole in an elliptical path, only to be pulled back in. At one point in this path, the debris collides violently with other parts of the star being pulled in, and that's when we start to see the first bursts of emissions. In some rare cases, tidal disruption events create huge jets of material that shoot out from the black hole's poles. If these jets happen to point directly at Earth, we can see the signature of the event. It often looks like an intermediate mass black hole eating a white dwarf star. However, there should still be some radio emissions coming from the jet of a tidal disruption event. The reason none have been detected yet might be that the event was likely observed too early. Previous studies suggest that it can take hundreds or even thousands of days for the jet material to slow down enough to start sending out radio signals. If future observations pick up radio emissions, it could help solve the mystery. But if there are no signals, it might mean it's a very unusual gamma ray burst or something completely new that we haven't seen before.
Imagine a basketball spinning on someone's finger. A point near the middle of the ball takes longer to spin back to where it started than the spot where your finger is. Earth spins in much the same way. People in the center of Africa are turning at 1,000 miles per hour as the planet rotates, while anyone at the South Pole doesn't really move at all, other than rotating in place. At the same time, we're all moving forward through space equally fast, since the planet is also hurtling around the sun at 67,000 miles per hour. The temperature at the boundary of our planet's inner and outer core is 10,800 degrees Fahrenheit. That's as hot as the surface of the sun. And the pressure there is 3.3 million times the atmospheric pressure at sea level. 2 or 3 years ago, an asteroid was pulled into Earth's orbit and started to travel around the planet. Even though it's no larger than an average car, it's still a big deal. Out of more than 1 million asteroids astronomers know about, it's only the second one to orbit our planet. Called 2020 CD3, it's our temporary mini-moon. It won't be with Earth for long, though. The asteroid is following a random orbit and is slowly drifting away. Temporarily captured objects, such as 2020 CD3, are rare. They need to have a specific direction and speed to be caught by Earth's gravitational pull. Otherwise, they either crash into the planet or fly in another direction. The movement of galaxies and clusters billions of light years away from us suggests there's some enormously massive body outside the visible universe. After billions of years, the expansion of the universe will make the space so sparse that we won't be able to see the stars in the sky at all. The moon isn't a perfect sphere. It's shaped like an egg. Plus, the satellite's center of mass is a bit more than a mile off its geometric center. Even though Venus is the hottest planet in our solar system, it still has snow. But not what you'd expect. It snows metals and rains acid. Not a great vacation spot. Saturn is mostly composed of hydrogen and helium, with some traces of methane, ammonia, and water. But it contains more sulfur than Jupiter, which gives the planet a smog-like orange hue. On Earth, sound waves make air molecules vibrate, which is why we're able to hear sound. Other planets and moons allow sound to travel through mediums like their atmospheres and oceans too. In space, though, it's said that there is no sound, since there aren't any molecules to vibrate and deliver sound waves. However, not all researchers agree on this, given that space isn't just a desolate vacuum. In between the emptiness, there are clouds of gas and other stray particles. So, depending on where you are, sound waves can be possible. Astronomers know for sure that the universe is growing bigger, and the speed at which it's ballooning is increasing all the time. But if the whole thing is swelling into something bigger, then it must have some kind of an edge, right? It's unlikely that people will ever find out, but if so, then what would it be? A ginormous brick wall and then nothing? An abyss that leads to nowhere? The most common theory is that the universe is shaped in such a way that it can't have an edge, but it's not the only idea. Another theory is even more difficult to comprehend. The universe is, indeed, infinite, and our part of it isn't that unique. It means that somewhere out there, there's another you, or rather, other you. One of them is just a bit shorter, another wears their hair in a different way, and the third one is identical to you in all possible ways. There's also a theory about a multi-universe that consists of many smaller universes, and the universe we live in is just a tiny bubble among other similar bubbles. Those scientists who support this idea are also sure that bubble universes can come into contact with one another. Then gravity starts to flow between them, and when 2 or 3 universes connect, a big bang occurs, just like the one that created our home universe. Neptune is the windiest place in the solar system. Clouds of frozen methane are whipped across the planet at a speed of 1,200 miles per hour. Neptune's core is solid and consists mostly of iron and some other metals. Its mass is 1.2 times bigger than that of Earth. The temperature inside reaches 9,000 degrees Fahrenheit. Astronomers also believe that at a depth of 4,500 miles, there might be a diamond layer where it's raining diamond crystals. On Earth, people are used to a beautiful sunset that's painted in hues of orange, red, and yellow. On Mars, however, the normally pinkish red sky turns blue as the sun goes down under the horizon. It's because Mars is much farther away from the sun than Earth, making the sunlight less intense. The fine dust in the Martian atmosphere absorbs the blue light and gets rid of the warmer colors that you typically see on Earth. Whether it's blue or yellow, both sunsets look spectacular. At around a quarter of the size of Earth, the Moon is pretty enormous relative to other satellites out in space. There's nothing quite like this situation anywhere else in the solar system. Pluto has a moon that's almost half as big as itself, but it's more like a twin than a satellite. There are more than 150 moons in our solar system, and Earth's is the fifth largest out of the whole lot. There might be a labyrinth of lava tubes on the Moon. Not long ago, astronomers received the results of an underground lunar topography. They discovered a massive cave under the satellite's surface. About 30 miles long and 60 miles wide, the cave's likely to be the result of 3-billion-year-old volcanic activity. After streams of lava hardened, they created a thick, hard crust on the outside. But inside, lava kept flowing, melting the rock and forming tunnels and caves. Countless pits in the Moon's surface discovered by NASA might be the openings to lava tubes. We can't dig up most of Earth's gold. 99% of it ended up in the center of the planet several billion years ago, attracted by the iron in Earth's core. We're talking about 1.6 quadrillion tons of gold here. That's enough to coat the entire planet's surface in 1.5 feet of the stuff. And if all those meteorites hadn't later smashed into the ground, bringing extra amounts of gold, it would be even rarer. Not so long ago, astronomers discovered a massive blob of some mysterious substance. It was hidden underneath the surface of the Moon's far side. Its mass was the same as that of a pile of metal 5 times larger than the big island of Hawaii. The enigmatic something lies almost 200 miles beneath an enormous crater that appeared on the lunar surface billions of years ago. The blob likely has something to do with a super collision. It might be the metal core of the object that hit the Moon back then. Scientists can't wait to lay their hands on the discovery. It could explain lots of things about the South Pole Aitken crater, the largest known in the solar system. If it was on Earth, its oval-shaped basin would stretch from Washington, D.C. to Texas. In 2011, astronomers discovered an enormous water reservoir simply floating in space around a supermassive black hole called a quasar. Floating water vapors have been found throughout the universe, but they aren't that common. This particular reservoir holds around 140 trillion times the amount of water in the Earth's oceans. It's one of the oldest, largest, and, at more than 12 billion light-years away, one of the farthest things known to humankind. Astronauts in space can lose about 1% of their muscle mass each month. To prevent this, they have to stick to an exercise regimen that lasts 2 hours every single day. The Milky Way galaxy and the Andromeda galaxy are going to meet in 3.75 billion years. They're moving toward each other at a breakneck speed. When the two galaxies collide, they'll form a huge elliptical galaxy. I won't be around then. Have you ever looked up at the night sky and tried to count all the stars? Yeah, good luck. Our galaxy, the Milky Way, has about 100 billion stars, but other estimates put it at over 200 billion, since calculating the exact amount is an almost impossible task, even for astronomers. As for the entire universe, there are at least 1 billion trillion stars. That's one with 21 zeros after it. For comparison, that means there are more stars in space than there are grains of sand on all of the Earth's beaches.
So, astronomers have just announced that they might have found signs of possible life on a planet outside our solar system. Wow! This distant world is called K2-18b, and it sits about 124 light-years away in the Leo constellation. So, what life are we talking about? Little green men? Octopus-like tentacled creatures? Well, not exactly. First things first, let's define what life is. It's what distinguishes animals and plants from inorganic matter, like the ability to grow, reproduce, and change. Now, what do we need to support life? If what comes to your mind is water, bingo! Scientists have the feeling that K2-18b might be covered in oceans, and if it's so, it can support tiny forms of life like microbes. A team of researchers from the UK and the US used the James Webb Space Telescope to look at the planet's atmosphere. They found hints of two very special chemicals. On Earth, only living things can produce those, and the living things I'm talking about are mostly tiny ocean plants called phytoplankton. So, basically, this planet might indeed host life in the form of algae. Now, of course, scientists still need more proof before getting too excited. We should keep in mind that it's possible that those chemicals were made by something we don't understand yet, not necessarily by living things. But still. K2-18b is a big boy. It's more than 8 times heavier than Earth and about 2.5 times larger. So, what makes it even more interesting is that it's located in the Goldilocks zone around its star. That means it's not too hot and not too cold there, just right for the existence of liquid water, which is highly important for life as we know it. Astronomers study faraway planets like this by watching how their light changes when they pass in front of their star. This allows us to figure out what kinds of gases are in the planet's atmosphere. Back in 2013, the James Webb Space Telescope found methane and carbon dioxide in the atmosphere of the planet. These are carbon-based molecules, and it was the first time they were found on a planet in the habitable zone. Scientists also saw a weak signal of a chemical called DMS, which is mostly made by tiny ocean life here on Earth. So, the researchers pointed the telescope at the planet again a year later using a different tool that could pick up more light details. This time, they found much stronger signs of DMS and some related chemicals. But the problem is the signals aren't strong enough yet. They haven't reached something called the 5 sigma level, a parameter scientists use to confirm discoveries. Plus, even if the DMS really is there, it doesn't automatically equal the existence of life. Scientists once found DMS on a comet, which means that it can be produced without some kind of life taking part in the process. And still, the amount of DMS on K2-18b looks way higher than anything seen on Earth. That's why some astronomers are sure it's coming from something living. K2-18b has been a top pick for what scientists call a Hypothetical planet. This term means a big, watery world with thick hydrogen atmosphere. It's not the kind of place where extraterrestrial civilizations like in movies would live. But it could be home to tiny life forms, like the microbes that once lived in Earth's oceans billions of years ago. Once again, not everyone agrees on how friendly K2-18b really is for life. Some scientists think planets like this might actually be too close to their stars to hold on to liquid water. K2-18b orbits its star every 33 days, which is pretty fast, and could mean it's too hot. That's why some experts claim that even if the planet has any water at all, it might be boiling. Or maybe it's not water, but oceans of lava. But most scientists agree on one thing: we should wait and see. With just 16 to 24 more hours of telescope time, astronomers could confirm what they've seen. This could happen in the next few years. And even if it turns out K2-18b isn't the world we're looking for, we're still getting close. With powerful telescopes like James Webb and more coming in the future, we might be able to answer whether we're alone in the universe or not. At the same time, some places in our own solar system, like Mars, Venus, or Saturn's moon Enceladus, might actually have a better shot at hosting life. Or we could keep exploring other promising worlds, like Proxima Centauri b, which is the closest exoplanet we know about. It's just 4.25 light-years away from us and orbits a small star called Proxima Centauri, right in the habitable zone. This planet is a bit bigger than Earth, which makes it a super-Earth. That's what we call exoplanets larger than ours, but much smaller than gas giants like Neptune or Jupiter. Proxima Centauri b is a fast-moving world. It needs a mere 11 days to go all the way around its star. Scientists think Proxima Centauri b might have a rocky surface, and that's a good sign for possible life. On the other hand, its star blasts it with a lot of ultraviolet radiation. It might have already destroyed the planet's atmosphere, if there was any to begin with. So there's a big question mark when it comes to this world's habitability. Then we've got TRAPPIST-1e, another promising Earth-like planet. It's one of 7 rocky planets orbiting a small, cool star called TRAPPIST-1, about 39 light-years away. Discovered in 2017, it might be one of the most promising places to look for life beyond Earth. This planet is actually a bit smaller than Earth, with a mass around 1/2 that of our planet. It completes an orbit around its star in just 6 days, which is super fast compared to Earth's 365 days. The planet's size and density suggests it has a rocky surface, and that's another key factor when we talk about habitability. Even though TRAPPIST-1e is very close to its star, the star is quite dim and cool, so the planet might still have a stable Earth-like climate. Some scientists even think it could have more water than Earth. Let's move on to Kepler-186f, located about 500 light-years away. It was the first Earth-sized planet found in a habitable zone of another star. It orbits a red dwarf, which burns cooler and lives much longer than our Sun. This means Kepler-186f could have stable conditions for billions of years, giving life plenty of time to possibly form and evolve. The planet gets only about 1/3 of the sunlight Earth receives, so it would likely be cooler but still warm enough to keep water from freezing. It also seems to be a rocky planet just like Earth, which boosts its chance of hosting life. Now, how about visiting LHS 1140b, about 40 light-years away? This planet has about 5.5 times the mass of Earth. Scientists think it's rocky and possibly has a thick atmosphere, which is a big deal. An atmosphere like that can trap heat, keep temperature stable, and protect water from escaping into space. This world orbits a quiet red dwarf star, so it's not constantly blasted by harmful flares like some other exoplanets are. Some studies even suggest LHS 1140b could be an ocean world with lots of water. So it's one of the more exciting planets we've found in our neighborhood. And finally, we have Gliese 12b. Astronomers call it Exo-Venus. It sits 40 light-years away from Earth. This world is about the size of Venus and orbits a cool red dwarf star. It needs just under 13 days to complete one orbit. The temperature on the planet is around 107 degrees, which is quite warm but still okay for life. The thing that makes Gliese 12b so interesting is that it could help us understand how Earth-sized planets around cool stars hold on to their atmospheres. That's important because an atmosphere is crucial for things like liquid water and protecting life from harmful radiation. According to some researchers, Gliese 12b is one of the best chances we have to figure out whether planets like this can stay habitable. Venus most likely used to be covered with oceans, from 30 to 1,000 feet deep. Also, some water was locked in the soil of the planet. On top of that, Venus had stable temperatures of 68 to 122 degrees Fahrenheit, which, you have to admit, was quite pleasant and not that different from the temperatures on Earth nowadays. So, what I'm getting at is that for 3 billion years, right until something irrevocable happened 700 million years ago, Venus could have been habitable. But now it's not. The Moon is the second brightest object in our sky. At the same time, among other astronomical bodies, it's one of the dimmest and least reflective. Our natural satellite only seems bright because it's so close to Earth. For comparison, our planet looks much brighter when you look at it from space. It's because clouds, ice, and snow reflect way more light than most types of rock. Triton, Neptune's moon, has all its surface covered with several layers of ice. If this satellite replaced our current moon, the night sky would get 7 times brighter. Neutron stars are some of the smallest yet most massive objects in space. They're usually about 12 miles in diameter, but are several times heavier than the Sun. Oh, and they also spin about 600 times per second, far faster than your average figure skater. Saturn is the least dense planet in the solar system. It has 1/8 the average Earth's density. And still, because of its large volume, the planet is 95 times more massive than Earth. A transient lunar phenomenon is one of the most enigmatic things happening on the Moon. It's a short-lived light, color, or some other change on the satellite surface. Most commonly, it's random flashes of light. Astronomers have been observing this phenomenon since the 1950s. They've noticed that the flashes occur randomly. Sometimes they can happen several times a week. After that, they disappear for several months. Some of them don't last longer than a couple of minutes, but there have been those that continued for hours. The year was 1969, one day before Apollo 11 landed on the moon. One of the mission participants noticed that one part of the lunar surface was more illuminated than the surrounding landscape. It looked as if that area had a kind of fluorescence to it. Unfortunately, it's still unclear if this phenomenon was connected with the mysterious lunar flashes. Trash isn't just a problem in Earth's oceans, cities, and forests. There is a thing called space junk, which is any human-made object that's been left in space and now serves no purpose. There's also natural debris from meteoroids and other cosmic objects. There are currently over 500,000 pieces of space debris orbiting the Earth at speeds high enough to cause significant damage if they were to collide with a spacecraft or satellite. NASA does its best to track every single object to ensure that missions outside Earth can reach their destination safely. Our Sun is insanely massive. Want some proof? 99.86% of all the mass in the solar system is the mass of the Sun. In particular, the hydrogen and helium it's made of. The remaining 0.14% is mostly the mass of the solar system's 8 planets. The Sun's temperature is hotter than the surface of a star. The surface temperature reaches 10,000 degrees Fahrenheit, but the upper atmosphere heats up to millions of degrees. If someone could dig a tunnel straight into the center of the planet and out the opposite side, and you were adventurous enough to jump into it, it would take you 42 minutes to fall to the other side. You'd speed up as you fell, reaching maximum speed by the time you reached Earth's core. After the halfway point, you would then fall upwards, getting slower and slower. By the time you reached the opposite surface, your speed would be back to zero. Unless you managed to climb out of the hole, you'd immediately start falling again, back down or up to the other side of the planet. This trip would go on forever, all thanks to the weird effects of gravity. Hey, might be a fun way to spend an afternoon. There might be more metals, for example, titanium or iron, in lunar craters than astronomers used to think. The main problem with this finding? It contradicts the main theory about how the moon was formed. That theory says that Earth's natural satellite was spun off from our planet after a collision with a massive space object. But then, why does Earth's metal-poor crust have much less iron oxide than the Moon's? It might mean the Moon was formed from the material lying much deeper inside our planet. Or these metals could have appeared when the molten lunar surface was slowly cooling down. Or maybe, as they've been saying for centuries, it's made of green cheese. Earth could have been purple before it turned blue and green. One scientist has a theory that a substance existed in ancient microbes before chlorophyll. That thing that makes plants green evolved on Earth. This substance reflected sunlight in red and violet colors, which combined to make purple. If true, the young Earth may have been teeming with strange purple-colored critters before all the green stuff appeared. The highest mountain in the solar system is Olympus Mons on Mars. It's 3 times as high as Mount Everest, the Earth's highest mountain above sea level. If you were standing on top of Olympus Mons, you wouldn't understand you were standing on a mountain. Its slopes would be hidden by the planet's curvature. Astronomers have found a massive reservoir of water in space, the largest ever detected. Too bad it's also the farthest, 12 billion light-years away from us. The water vapor cloud holds 140 trillion times as much water as all the Earth's oceans combined. What are we supposed to do with that information? Venus spins at its own unhurried pace. A full rotation takes 243 Earth days, and it takes the planet a bit less than 225 Earth days to go all the way around the Sun. It means a day on Venus is longer than a year. There's very little seismic activity going on inside the Moon. Yet many moonquakes, caused by our planet's gravitational pull, sometimes happen several miles below the surface. After that, tiny cracks and fissures appear in the satellite surface, and gases escape through them. Hey, they sometimes escape from me, too. Now, Mars is the last of the inner planets, which are also called terrestrial since they're made up of rocks and metals. The red planet has a core made mostly of iron, nickel, and sulfur. It's between 900 and 1200 miles across. The core doesn't move. That's why Mars lacks a planet-wide magnetic field. The weak magnetic field it has is just 1/100th% of the Earth's. When the planets in the solar system were just starting to form, Earth didn't have a moon for the longest time. It took 100 million years for our natural satellite to appear. There are several theories as to how the moon came into existence, but the prevailing one is the fission theory. Somebody went fishing and caught the moon? Actually, no. The fission theory proposes that the moon was formed when an object collided with Earth, sending particles flying about. Gravity pulled the particles together, and the moon was created. It eventually settled down on the Earth's ecliptic plane, which is the path that the moon orbits. So, looks like the green cheese is off the table now. The largest single living thing on Earth turns out to be a mushroom in Oregon. This enormous honey mushroom lives in Malheur National Forest and covers an area of 3.7 square miles. It could be as much as 8,500 years old. You could be forgiven for missing it, though, since most of it's hidden underground. When the roots of individual honey mushrooms meet, they can fuse together to become a single fungus, which explains how this one got so big. If you could gather all that mushrooming stuff into one big ball, it could weigh as much as 35,000 tons. That's about as heavy as 200 gray whales. Hey, that's a whale of a mushroom. Hehe. The largest asteroid in the solar system is called Vesta, and it's so big that it's sometimes even called a dwarf planet. A trip to the nearest star, apart from the Sun, would take you 5 million years on a commercial airplane. That's what I call a long-haul flight. Space isn't supposed to be black. There are stars everywhere. Shouldn't they light up everything around? Well, you don't see stars wherever you look because some of them haven't existed long enough for their light to reach Earth. A day on Uranus lasts 17 hours, 14 minutes, and 24 seconds. But get this, the planet has a tilt of around 98 degrees, and that makes a season on the gas giant last 21 Earth years. Now, some scientists believe that our planet used to have an additional satellite. According to their research, a small celestial body about 750 miles wide orbited Earth like a second moon. It most likely crashed into our main satellite later on. Such a collision could explain why the two sides of the moon look so different from each other, one being heavily cratered and rough. Or it could be the green cheese.